Okay, so now we're going to look at how changing concentration affects equilibrium. If we increase the concentration of the reactants, that's going to favor the forward reaction, or equilibrium is going to shift to the right. That's because if we increase everything over here, then equilibrium is going to shift that way to try and compensate. Equally, if we removed reactants or we decreased the concentration, equilibrium would shift back left, or it would favor the backward reaction. Same in reverse. If we increased the concentrations over here, it's going to shift equilibrium back left. If we decrease the concentrations here, then it's going to shift the equilibrium right. And that is the most common thing to do in industry. If you pipe off your reactants, your products as they're made, then the reactants are going to keep shifting equilibrium that way. So it's going to favor the forward reaction, which is exactly what you want to do in industry, because you want to make the most amount of products. So most often they remove the products as they're made. If it's a gas, it doesn't work in solids or liquids, I'm afraid, but you can increase the pressure. Now, if you increase the pressure, the reaction will favor the side with the fewest moles. So you just add up how many moles are over here and how many moles are over here. Now, for those of you who are struggling to remember C6, moles is just big numbers. You just count the big numbers. So in this case, if there's no big number, it means 1 mole. So you've got 1 mole of A plus 2 moles of B. So 3 moles in total, 1 plus 2 on this left-hand side. On the right-hand side, you've got 2 moles. So in this reaction, for example, if you increase the pressure, you would favor the forward reaction, or we would say equilibrium would shift to the right. Again, whichever way suits you. Favor the forward reaction, equilibrium shifts to the right is exactly the same thing. So let's have a look at an exam question. This one again is about the contact process here. But again, even if we know nothing about the contact process, it really doesn't matter. We just apply the rules that we've learned. A low pressure, 2 atmospheres is used. At equilibrium, about 98% of sulfur trioxide is present. What is the effect on the position of equilibrium of using a higher pressure? Only 1 mark. So you literally have to state the effect. You don't have to explain it. And explain why a higher pressure is not used. So here, you need to give a reason for your choice because it says the word explained. If you used a higher pressure, then equilibrium would shift to the right. Or we could say it favors the forward reaction, because the increased pressure would favor the side with fewer moles. You only have 2 moles over here, but you have 3 moles over here. So equilibrium is going to shift right. Why then is a higher pressure not used? Why does it only in industry use 2 atmospheres? Well, you've already got 98% over here. So why would you need to put in extra money, extra time, extra resources? Why would you need better equipment to maintain the pressures? 2 atmospheres is enough. 98% is already a really, really high yield. So that's why you wouldn't use it.